Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022, Paper 1, Variant 1. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding and you can understand concepts in a better way. So next time, you can do these questions by yourself. Let's study together. Let's improve together. In today's class, we are talking about October-November 2022, Paper 1, Variant 1. And total time for this exam is 1 hour and 15 minutes, and total mark for this paper is 40, and there are 40 questions in this paper. So it simply means that we have 75 minutes in total, 75 minutes in total, and there are 40 questions. So you have about 1.8 minutes per question, means for each question. But this is not to just spend 1.8 minutes on each question. You need to understand some smart ways to answer multiple choice questions in exam, means under time conditions. So the best way to approach these questions is, first of all, go through easy question, mean the question you look at them and you can find the answer. So you can answer those questions first of all, and then you can come back and you can start working on hard questions. And don't stuck with one question. For example, if one question you can't figure out the answer, you can try to find answer by elimination method. You can eliminate the options that are not possible and you can choose the best possible option. So you should not just stuck with one question. So very important. And how you can improve your techniques or your methods to answer questions in exam, at least 1 month before exam, you can start solving past paper by setting time. Means try to do paper in 1 hour only. 1 hour, not in 1 hour and 15 minutes. On next page, you can also see some data, means values of some constants are given to you. If you need value of any constant for some calculations in your exam, you can come back to this page and you can find the values. On the next page, actually is on the same page, some formulae are also given to you. So these formulas are not all formulae you need for AS physics, but some of formulae are given to you. So if you have forgotten any formula, you can come back to this one and you can recheck. But it is better as a physics student, it's very important if you can remember them, or you need to understand how to derive these formulae. So that is the best thing, because you will need these formulae for your whole life. I mean, when you go to university, you also need these basic formulae. So it's better to remember them, and also you need to understand how to derive these formulae, because when you derive formula, if you understand how to derive a formula, it means you have better understanding about physics concepts behind that formula. So always try to understand how to derive formula. Let's go to next one and start working on questions now. For question number 1, it is given to us what is needed to accurately represent all physical quantities. So first of all, we need to understand what is a physical quantity. A quantity that can be measured, we can call is a physical quantity. A quantity that can be measured, we can call that quantity is a physical quantity. And most of the physical quantities, they have unit. Most of the physical quantities, they have unit, and also they have numerical magnitude. So they have unit and also they have numerical magnitude. Most of the physical quantities, they have unit and they also have numerical magnitude. But physical quantity like strain, means strain is a ratio between two same physical quantities. So strain has no unit. But most of the physical quantities, they have unit and they also have numerical magnitude. So when we represent physical quantities, we use unit and numerical magnitude. So physical quantities, they have unit and they have numerical magnitude. So this is the point you need to understand. Now if you look at first option is given to you is a base unit and a number. So that is not possible. Not a base unit. It can be a unit, not base unit. Number is not good. It has to be numerical magnitude. A unit and a number expressed in standard form, we no need to express physical quantities in standard form. So this is also not possible option. A unit and a numerical magnitude. magnitude. So this one is best possible answer. So this is our answer. An SI unit is not required. You can use any unit that is not even part of SI system. And a numerical magnitude. This is right, but this is not required. It can be any unit we can use for physical quantities. So the answer for this question is C, and this is what you need to understand. How do we represent physical quantities? We represent them by unit with numerical magnitude. For example, we have 5 kg, so we have 5 kg. So this one is the unit. So this one is unit, and this is numerical magnitude. So this one is numerical magnitude. Numerical magnitude. This is numerical magnitude. And also, let's say we have 6 newtons. So this is representing force. So this is numerical magnitude. So I can say this is numerical magnitude, and N is the unit. So physical quantities are represented by unit and numerical magnitude. So this is what you need to understand. But physical quantity like strain has no unit because it's a ratio between two same quantities. For our second question, it is given to us a voltmeter connected across a resistor in a circuit reads 3.6 volts. What could be the current in the resistor and the resistance of the resistor? So in this case, V is given, potential difference is given to us. If you want to sketch this one, so simply you can also sketch in this case. So this one is resistor. So we can say this one is resistor. And voltmeter is connected across this one. So you can imagine this one is the voltmeter. And the reading of this voltmeter is given. Then that reading is equal to 3.6 volts. Now question is asking us what is the value of I and what is possible value of R, but we need to understand potential difference across this resistor is equal to the product of current passing through this resistor and resistance of this resistor. So simply we need to multiply these two quantities and we need to find out which one is equal to 3.6 volts. So first of all, you can multiply these two. So we have 150 milliamps. So you have to be careful with units. And here we have this is 0.24 times 10 to 3. So this we can simply cancel. And if you solve this one, you will get in this case 36 volts. So this is not possible answer. So we can also go to the next one. You can try next one. So in this case, you have 15 times 10 to minus 3 times you have 2.4 times 10 to 3. So if you multiply these two quantities, so as it was cancelled here, so these powers will be cancelled and these powers also will be cancelled. So if you multiply 15 with 2.4, you will get this is 36 volts. Now we can go to next one. So you have to repeat the same process, simply I times R, and this is 10 to minus 3 times we have mega. This is 0.24 times 10 to 6 mega. So in this case, your answer will be 360 volts. So this is also not possible answer. So we can go to the last one. So this one has to be the answer. So this is not possible answer. This is not possible. This is not possible. So this one has to be the answer. So if you multiply 15 microamps, this is 10 to negative 6 multiplied by 240 times 10 to 3. So you will get final answer. That one will be equal to 3.6 volts. So this is the answer. So main concept in this case is simply you need to understand potential difference across a resistor is equal to the product of current passing through resistor and resistance of resistor, and you can figure out. So answer is D. For our third question, it is given to us in an experiment to determine the acceleration of free fall g, the time taken for a ball to fall through a distance s is measured. The percentage uncertainty in the measurement of s is 2% and percentage uncertainty in the measurement of time is 3%. The value of g is determined using the equation shown. So we can use this equation and we can calculate value of g. And we need to find out what is the percentage uncertainty in the calculated value of G. So the first thing we need to understand, in this case, G is equal to 2S by T square. So these quantities, they are multiplied and divided. So when quantities are multiplied or divided, percentage uncertainties are added. So in this case, simply we can say delta G by G. So this is the percentage uncertainty in G. That one has to be equal to the percentage uncertainty in S. So we can say that has to be equal to delta S by S, means the percentage uncertainty in delta S plus percentage uncertainty in T, means delta T by T, and this one has to be multiplied by 2 because the power of T is 2. And now simply we can use the values given to us. For S, percentage uncertainty is given, that is 2%, and percentage uncertainty for time is given, that is 3%. So we can write down this one is 3%. So the final answer we will get, that is 8%. So this is the percentage uncertainty in calculated value of G. So the point is that you need to understand when quantities are multiplied or divided, percentage uncertainties are added, and we no need to consider this scale factor. Even if we consider ratio will be the same, because ratio will be the same, so we no need to consider this scale factor. So this is how you need to approach this type of problems. For question number 4, simply we need to find out which quantity is a vector quantity. Momentum is a vector, so this can be the answer, but speed is not vector, temperature is not vector, Young's modulus is not vector because it's ratio between stress and strain. So the answer for this question is A. Very straightforward question. For question number 5, it is given to us a particle accelerates from rest. The graph shows the variation of the velocity v of the particle with time t. So in this case, if you look at this graph, we can see the gradient of this graph is constant, and gradient of this graph is equal to acceleration. So gradient is equal to acceleration, and acceleration in this case is constant. So this is the first thing we need to understand. Acceleration is constant because gradient is constant and gradient is representing acceleration. Now we need to find out which graph shows the variation of the velocity v with acceleration of the particle. And acceleration in this case is constant, means acceleration is not changing with time, but speed is increasing with time. If we look at option A, this is telling us acceleration is increasing, but that is not possible because acceleration has to be constant. This is also telling us acceleration is increasing with velocity, so that is also not possible. And this is telling us velocity is constant, but acceleration is increasing, that is not possible. So only possible answer for this question is A, because acceleration is constant, then velocity is increasing. So the answer for this question is D. So you need to read question carefully. You need to understand what is given to you and how you can figure out the answer. So in this case, this graph is very important because we have velocity against time graph, and gradient of this one is constant, and gradient is representing acceleration. So acceleration has only one value. So that's the reason our answer is D. For question number 6, it is given to us the graph shows the vertical velocity of a parachutist during first 20 seconds of her jump. Approximately, we need to find out how far does she fall before opening the parachute. Before opening the parachute means she is opening parachute at this point. So first thing, we need to mark this point. So she is opening at this point. Now we need to find out the distance, and we have velocity against time graph. So simply we need to calculate area under this graph. So simply first of all, we can draw this line here, means we need to find out area. This area we need to figure out, this area, and we can divide this area into two parts. We can simply divide this area into two parts. One part we can draw this rectangle, and we can also draw a triangle. So this is the triangle. Now we need to calculate this area. So first of all, we will try to figure out this area. So this one, this area we will try to calculate, and then we will try to calculate this area, this one. So let me use this color so you can see which area we are calculating. So this area of triangle we need to calculate. So this area of triangle we will calculate, and area of rectangle. So this area of triangle. So we need to calculate area of triangle and area of rectangle. So let me use a different color for the second area. So this area of rectangle we need to calculate. So this area of rectangle. So these two areas we need to calculate, and then we can approximate distance. So these two areas. So first of all, in this case, we will calculate area of triangle. So area of triangle, or simply we can say, in this case, distance will be equal to area of triangle plus area of rectangle. And in this case, area of triangle, we have 0 here, and this is 10, and here we have 60. So simply this is 1 by 2 times 10 times 60, and area of rectangle, we have 10 here, so this is 11, 12, 13. So this is 13. So we have 3 times 60, and if we simplify, we can cancel this 2 with this, we will get 5 here, and we can multiply, we will get 300 here. And if we multiply 60 with 3, we'll get this is 180. So the total area is equal to 480. Mean the total distance travel. This is 480 meters. But 480 meters is not the actual value because we ignored this part. We didn't include this part. So we didn't include this part. It means the distance travel is more than 480. Actual distance travel is more than 480. So the first option is not possible because this is less than 480, and this is not possible because this is way big. So this is not possible. This is also not possible. So the answer should be close to 480. So the best approximation in this case can be B, and B is our right answer. So this is how you can approach this type of problems. I hope this one is clear. For question number 7, we need to find out what is definition of linear momentum. And linear momentum, simply we understand P is equal to mv, means the momentum is the product of mass and velocity. Because momentum is a vector quantity, so we need to say velocity instead of speed. So in this case, if you look at option 1, force per unit time, this is not definition of momentum. Product of force and time, this is impulse, so this is also not momentum. This represents change in momentum, or simply we can say this is impulse, force time, impulse. So this is also not momentum. Product of velocity and mass, this is definition of momentum. So this is representing momentum. So our answer for this one is C. Velocity per unit mass, this is also not momentum. So the answer for this question is C. Pretty straightforward one. Simply you need to understand momentum is equal to product of mass and velocity. For question number 8, it is given to us a mass of 0.20 kg is suspended from the lower end of a light string. Light string means that string has no mass. A second mass of 0.10 kg is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium, and then the thread is cut. Then this thread is cut. We need to find out immediately after the thread is cut, what is upward acceleration of 0.20 kg mass. So first of all, we have this arrangement, and this is in equilibrium. So this is given to us, this is in static equilibrium. Static equilibrium. So it simply means that we can simply find out the force in the spring, and we can draw the free body diagram. If we draw the free body diagram, in this case, the force acting downwards, that will be equal to the weight of these two masses, and that is 0.20 plus 0.10 times 9.81, and this one has to be equal to the spring force. So we can draw the spring force that is acting vertically upwards. You can also imagine that we can close these two masses in a box. So you can see now the mass inside this box is 0.20 plus 0.10 kilograms. So we can say spring force in this case will will be equal to 0.2 plus 0.1. So simply we can say this is 0.3 times 9.81 newtons, and this spring force is acting vertically up. Now it is given to us this thread is cut. It means this mass has been removed. So we can redraw this setup again. So we can redraw. So we have spring here, and there is only one mass that is attached with this spring, and that mass is 0.20 kgs. Now we need to understand, when we just cut the thread, at that moment, in that very short interval of time, Fs will not decrease. Fs will be equal to this value, means its value will not decrease. For a very short period of time, Fs will be equal to 0.3 times 9.81, and this is value of Fs. And the force acting downwards, that has been decreased, and that force will be equal to 0.20 times 9.81. So in this case, there is a resultant force, and resultant force is acting vertically upwards because the greater force Fs is greater than weight, and that is up. So in this case, acceleration also will be acting vertically upwards, and we need to find out value of this. In order to find value of A, so simply we need to use Fnet. Fnet will be equal to ma, and the mass of the system in this case is only 0.20. So we can use this formula. Fnet will be equal to Fs minus this force. So Fnet is equal to 0.3 minus 0.20 times 9.81. Then this is equal to mass of the system. Mass of the system is 0.20 times A. And from here we can find out value of A. So A will be equal to 0.3 minus 0.2. This will be equal to 0.1 times 9.81 divided by this mass, and mass is 0.20. And if we solve this one, our final answer will be 4.9 meters per second. So this is how you can approach this problem in a beautiful way. When we just cut the thread, spring force will take some time to adjust itself. So that's the reason spring force will stay same at that moment. So that's the reason we have said this force is equal to 0.3 times 9.81, and then you can figure out. I hope this one is clear to you, and the answer for this question is A. If you have any questions, you can leave in comments. For question number 9, it is given to us a snowflake and a raindrop are in still air. They both fall from west at the same time and from the same height far above the ground. The snowflake and raindrop contain the same mass of water. Assume that there is no evaporation or melting. Also assume that for a given speed, the drag force acting on snowflake is greater than drag force acting on the raindrop. So here, one thing we need to understand, they have the same mass. They have the same mass and the same height, but the drag force on snowflake is greater than drag force on raindrop. We need to find out which statement about the snowflake and raindrop is correct. So the best way is we can simply draw here. Imagine that this one is snowflake, and we can also have a raindrop, and imagine this one is the raindrop. They have the same mass, so we can write down here first of all, they have the same mass, both of them. They have same mass, they are dropped from the same height, so we can write down same height, but drag force Ft is greater for snowflake, is greater for snowflake. So these things are very important. We will be using these informations to answer this problem. Now we need to understand, in this case, snowflake mass is the same. It means the weight is the same, but this one will experience greater drag force. Drag force is greater for this one. So the Fnet we can find out. Fnet for this one, Fnet will be equal to ma. So the Fnet is weight minus the drag force. So this is drag force, and this is equal to ma. Now from here we can see A will be equal to W minus Ft divided by M. So if drag force is greater, it means that if this force is bigger, it means the average acceleration will be lower. So this is one thing we need to understand. So we will say the acceleration of snowflake S will be lower than acceleration of raindrop. So I'm just using R for raindrop. Acceleration will be lower. Now we can also compare the velocity. V is equal to U plus AT, but in this case they have initial velocity 0, so we can simply say V is equal to AT. Now we need to understand comparison between time. Snowflake, as the drag force is greater, so it will take shorter time to reach terminal velocity, because it will take shorter time because the drag force is greater, so drag force will balance the weight quickly. So we can say drag force balance weight quickly. Drag will balance weight quickly. Will balance weight quickly. So we can write down will balance weight quickly, because the value of the drag for snowflake is greater. Balance weight quickly. So it means in case of snowflake, time taken to reach terminal velocity will be shorter. So for snowflake, we can write down the terminal velocity Vs. This is equal to As, and this is equal to Ts. But in this case, we have seen that Ts is also shorter than Tr. Raindrop will take longer time to reach terminal velocity because drag force is small, so it will take longer time for the drag to reach same magnitude as magnitude of weight. So Tr will be greater than Ts. So from here simply we can conclude now that as this one will be smaller, this one will be shorter, so it means Vs for the snowflake will be smaller, lower terminal velocity for snowflake. We can also sketch this one. So imagine that we have in this case V against T graph. So if we sketch first of all for the snowflake, let's say this is for snowflake, it reached terminal velocity. We can say this is for snowflake, so it reached this terminal velocity. But if we sketch this one for the raindrop, raindrop will take longer time and its acceleration also will be greater, so maybe it reached terminal velocity somewhere here. So this is the terminal velocity. So this one will be for raindrop. Acceleration of raindrop greater because this gradient has to be higher than the snowflake, and it will take longer time, so it will reach higher terminal velocity. I hope this one is clear. So now you need to use this understanding and you need to answer the question. Let's try to understand this concept with the help of demonstration. Imagine that we have two papers. One, this is A4 size paper, is full paper, and this is also A4 size paper. So I will fold this one. I will just fold this one like this. So this is like a raindrop, and this one is like a snowflake. If I drop both of them from the same height, so which one will reach the ground first? I hope you will say in this case raindrop, because raindrop will reach a higher terminal velocity and it will be moving faster. If the distance is the same, this will reach the ground first. So this one will reach the ground first. So you can see here now, you can do this demonstration by yourself. So if I drop now, you will see raindrop means this folded paper, this one will be moving faster, and this paper means the snowflake, this will be moving slower. Its terminal velocity will be slower, its terminal velocity will be higher. So you can look at this demonstration. So you saw in this demonstration that raindrop reached the terminal velocity, higher terminal velocity means was moving faster, and reached the ground first, mean it took shorter time to reach the ground. So simply we can write down in this case raindrop will take shorter time to reach the ground, shorter time to reach the ground. So let me write down here shorter time to reach the ground, shorter time to reach the ground, shorter time to reach the ground, because it has higher terminal velocity to reach the ground. So raindrop, so this is we are talking about raindrop. So it will take shorter time to reach the ground because its terminal velocity is higher. Now let's try to find out answer. For option A, it is given to you the raindrop takes more time than the snowflake to reach terminal velocity. Yes, that's true, because raindrop drag force is lower at any given speed, so it will take longer time to reach the terminal velocity and its terminal velocity will be higher. So this one is possible answer. So this can be the answer. Now if we go to this option B, raindrop takes more time to reach the ground? No, it takes shorter time, as you have seen in demonstration. For part C, they reach same terminal velocity? No, raindrop terminal velocity is higher, so this is also not possible. They take the same amount of time to reach the ground? No, raindrop take shorter time. So answer for this question is A. I hope this concept is clear to you. For question number 10, it is given to us two trolleys are held together on a horizontal surface with a compressed spring between them. When they are released, the trolleys lose contact with the spring. The trolley of mass 2 kg moves to the left at a final speed of 2 meters per second. How much elastic tension energy was stored in the spring? So in this case, we need to understand the elastic tension energy stored in the spring will be converted into kinetic energies of these two trolleys. For this question, we have the speed of trolley of mass 2 kg. Speed of this one is given, so this goes to the left. So we can say speed of this one is v1, and that is equal to 2 meters per second. And the speed of this trolley we need to find out. Let's say speed of this trolley is v2. So we need to find out v2. So in this case, we need to understand, as initially this system is at rest, so the momentum of this system is 0, and momentum has to be conserved in this case because there is no net external force acting on this system. So the P initial has to be equal to P final. Initial momentum is equal to 0, so in this case we will take to the right as positive, to the right as positive. So the momentum of this one is positive and momentum of this one is negative. So we can write down 1 times v2, this momentum is positive, plus we need to add momentum of this one, and this momentum is negative because the velocity is negative. Now from here we can figure out this is v2, and here we have minus 4. So from here we can find out v2, this is equal to 4 meters per second. So this is the value of v2. Now we can calculate total kinetic energy. So we can say total Ke after. So we can say total Ke after, total kinetic energy. So that will be equal to 1/2 m mass of this one. We have 1 kg, and the speed of this one is 4. So we have 4 squared plus kinetic energy of this trolley. We have mass that is 2 kg, and the speed is also 2. So if we simplify this one, in this case we will get this is 8, and in this case we will get 4. So the kinetic energy is equal to 4 joules, and kinetic energy is equal to elastic potential energy. So EPE in this case will be equal to 12 joules. So this is how you can figure out answer for this problem. So the answer for this one is D. That's all for today's video, and a lot more videos will be coming very soon. If you really want to develop your understanding of physics, I have uploaded a lot of videos on my channel. You can find at least 350 videos. If you watch those videos carefully, your concepts will be very clear. And also, if you have any questions, you can leave your questions in comments, and I will be answering as soon as possible.